Good day and welcome. We are starting an exciting series on map skills, focusing on topographic and orthophoto maps. Today, we will dive into the fascinating concept of contour lines. For more on this topic, please check out the links in the description. Here's a question for you. Can you guess what contour lines reveal about the shape of the land? Share your thoughts in the comments below. Stick around until the end for some thought-provoking questions to test your understanding. Challenge yourself and see how well you've grasped the material. It's a fantastic way to boost your confidence. Don't forget to like and subscribe so you never miss our weekly uploads. Let's get started. Maps show the view of the land from directly above. Vertical aerial photographs also show a view of the land from directly above the ground. Map makers use vertical aerial photographs to help them make maps. In earlier grades you learnt part of the map language that helps you to read and interpret maps. Maps are not realistic in the same way that photographs are. We use symbols and color on maps to represent objects that are on the ground. Contour lines are fundamental elements on topographic maps that represent the elevation of the land. Contour lines are lines drawn on a map that connect points of equal elevation above sea level. They show the shape and height of the land, helping to represent hills, valleys, and slopes. Contour lines are a kind of symbol that is used to show height on maps, for example, the height and shape of a hill. Each contour line connects places that are the same height above sea level or altitude. The pattern made by different contour lines on a map shows the height and the shape of features on the land. We use contour lines on maps to provide information about the height and shape of landscape features such as hills, river valleys, and mountains. Let us study this diagram in more detail. The top view of this diagram provides a bird's-eye perspective of the mountain, using contour lines to represent elevation. Each contour line connects points of equal height above sea level, such as 100 meters, 200 meters, and so on, up to the peak at 800 meters. When looking at the top view, you'll notice that the lines form concentric circles, getting smaller and closer together as they approach the center. This indicates a gradual increase in elevation, leading up to the mountain's highest point. When you match the top view to the side view, it becomes clear how the contour lines represent the actual shape of the land. The side view shows the mountain's profile, or how it would appear from the side. In the top view, the contour lines spaced close together near the peak correspond to the steep slope shown in the side view. Conversely, the lines that are farther apart near the base indicate a gentler slope, as seen at the bottom of the side view. This connection between the top and side views highlights the key role of contour lines in revealing the shape and elevation of the land. The side view brings the mountain to life by showing how the height changes as you move upward, while the top view translates this information onto a flat surface, allowing you to visualize the land in 3 dimensions. A contour interval or vertical interval is the vertical difference between adjacent contour lines. You can also say a contour interval is the height difference between successive contour lines. By studying contour lines or reading contour lines, one can visualize the shape and relief of the land. The contour interval on this map refers to the vertical difference in elevation between consecutive contour lines. By observing the map, the contour lines are labeled with elevations such as 0, 50, 100, 150, 200, 250, and 300 meters. The difference between each consecutive line is 50 meters. This means the contour interval is 50 meters. The contour interval helps us determine the steepness of the terrain. The triangle in the middle of the contour map represents the highest point and is labeled 325 meters. This symbol is known as a trigonometrical station or trig beacon. It is a fixed survey point used by cartographers and surveyors to accurately measure elevations and distances on the map. The trig beacon is usually placed at prominent high points, such as hills or mountain peaks, because these locations provide clear lines of sight for mapping and surveying. In this map, the trigonometrical station marks the peak of the landform, with the surrounding contour lines showing a steady increase in elevation toward this point. Cartographers get information about the land from different sources including vertical aerial photographs, satellite images, and land surveys done by people on the ground. Cartographers use all the information they collect to produce detailed maps. Gradient describes the steepness of a slope. Steepness tells you about the angle of the slope. A slope will have a gentle gradient if the height difference between two places is small and the land distance is long, for example, a gently sloping field. Gentle slopes have contour lines spaced farther apart, indicating a gradual change in elevation. The further apart the contour lines, the more gradual the slope. A slope will have a steep gradient if there is a big difference in the height between two places, while the horizontal distance between the places is small, for example, a cliff. Steep slopes are characterized by closely spaced contour lines, suggesting a rapid change in elevation. The closer the contour lines are together, the steeper the slope. Contour lines can only connect to form a single contour line where there is a vertical cliff. To calculate the gradient of the slope between points A and B, we compare the vertical height difference, rise, to the horizontal distance, run, between the 2 points. The gradient tells us how steep or gentle the slope is. In this case, the vertical height difference between points A and B is 100 meters, and the horizontal distance is 1,000 meters. To determine the gradient, we divide the vertical height difference, 100 meters, by the horizontal distance, 1,000 meters. Gradient equals vertical height divided by horizontal distance. 100 meters is divided by 1,000 meters. This gives a gradient of 110. This result means that for every 10 meters traveled horizontally, the slope rises by 1 meter. The gradient is expressed as a ratio of 1 to 10. This ratio shows that the slope is gentle because the horizontal distance is much greater than the vertical rise. On the other side of the mountain, the slope is 1 to 5. For every 5 meters traveled horizontally, the slope rises by 1 meter. This is a much steeper slope compared to the other slope where 10 meters traveled horizontally also gives a 1 meter rise vertically. Gradients are useful for understanding the steepness of terrain, with smaller ratios indicating steeper slopes and larger ratios indicating gentler slopes. For more on calculating gradient of a slope using contour lines, please check the link below. Let us move on and talk about river valleys and contour lines. River valleys are lower than the surrounding land. They may have a river flowing in them. In mountain areas, river valleys have steep sides. The contour lines for a river valley make a V-shaped pattern. The V of the contour line always points up the valley. The sharp V-shaped contours point towards higher ground. Contour lines that form a V-shape indicate a river valley, with the apex pointing upstream. In lower areas, river valleys may be very wide with flat land on either side of the river. The contour lines will be far apart where the slope of the valley is gentle. A valley usually has some form of river or stream present. The spur is the higher lying ground adjacent to the valley. Spurs are pieces of land that stick out between different river valleys. Spurs can have steep or gentle gradients. The contour pattern showing spurs is U-shaped. The closed part of the U points down the slope towards the lower contour numbers. You could say the rounded U-shaped contours point towards lower ground. Spurs will not have rivers present. These features are essential for planning routes and understanding how water flows through the landscape. Contour lines are very useful for hikers, geographers, and planners. They help people find the best routes to follow, predict changes in height, and understand how difficult the land will be to cross. Contour lines can also show important features like mountain peaks, valleys, and saddles. Learning how to read contour lines, including understanding slopes, river valleys, and ridges, helps people improve their map reading skills. These skills are useful for many activities, such as hiking, exploring new areas, scientific studies, and planning towns and cities. We are coming towards the end for today. We have seen that contour lines help us visualize the shape and elevation of the land. By studying steep and gentle slopes, we can measure gradients and determine how land rises or falls over distances. Recognizing river valleys and spurs allows us to interpret the flow of water and the ridges that shape our landscapes. But before we go, please attempt the following questions before the answers pop up. You can pause the video as you go. This is an important section that consolidates what you have learned. In the next video, we will be looking at orthophoto maps in more detail. Be sure to check out the link for this in the description for more videos. Also, please do not forget to like and subscribe so that you do not miss our weekly uploads. Otherwise, thank you for watching and keep well.